I believe we have 3 examples to finish in the notes where we left off on Friday. So we are at the bottom of lesson 7.1 on the backside, yes? We've done the top 2, and we had worked with examples there and used the formula, and were able to find the amount of money after certain interest and all that. Well, let's look at this next example here. Suppose you invest $1,000 in a savings account that pays 5% interest. If you make no additional deposits or withdrawals, how many years will it take for the account to grow to at least $1,500? Okay, let's reread through that and see if we can identify some information. Suppose you invest $1,000. What do you remember?
That's your starting value.
That's our starting value. That's our initial value. In our formula, that is going to be little a. Okay. In a savings account that pays 5% interest. What is this 5% interest?
Percentage.
Our percentage rate. And what are we going to use when we plug this into the formula? Do we use 5?
0.05.
0.05, yes. We move the decimal 2 places left. And so this is a 0.05. If you make no additional deposits or withdrawal, how many years? What are they asking me to find here? Time. They're asking me to find T. How many years will it take for the account to grow to at least $1,500? What is that $1,500?
Your amount. After T years.
Yeah, that's your amount after T years. That's what I'm going to call A of T. So we had a formula at the beginning of the top of the page, right? Formula was A of T equals A times 1 plus R raised to the power of T. So I'm going to say fill in what you can here. As we fill in what we can, what's going in for A of T? The amount we're trying to get to is 1,500 equals little a, what's our initial value? So 1,000 times 1 plus R. What is R? 0.05 raised to the power of T, which is actually what we're trying to find here. Now, there's one little small bit of cleanup we can do there, yes? Within the parentheses, what is 1 plus 0.05? 1.05. So this is going to be 1,000 times 1.05 raised to the power of T. And then our goal here is we're trying to figure out when does that equal 1,500? Now, do we have a way to solve this equation for T? Do we have a method to solve for the power? Is that something we've done before? No, we don't. At this current time in Algebra 2, we do not have a way to solve that equation for T. Okay? Now, give us another week or so and you actually will have a way to solve it. But for right now, we don't. What are your thoughts on what we can do here?
But not replace T with 9.
Did you just randomly pick 9 out of thin air?
I started with 10 and I worked my way down.
Okay. So what's Levi basically saying here? Just guess and check, right? You have a calculator in front of you, yes? Okay? He's saying we're going to guess and check. Now, to kind of keep track of our guess and check, because I'm going to back it up a little bit more before then. Okay? But I'm going to set up kind of a horizontal chart here where I have T on top and A of T on bottom. It comes down to picking a number to start with, yes? Now, it was last Friday that we did this, but look up at the top example on this page. What do you notice at the top example on this page? It was 1,000, right?
Mm-hmm.
It was 5% interest, right?
Mm-hmm.
And what did we have there?
6 years.
We had 6 years. And so when T is 6, what was A of T? $1,340.10. I'm using that as my starting point because we kind of already did the math on Friday, didn't we? Now, what do we know? We're looking for at least 1,500. So we know 6 is,
At least.
yeah, but are we there yet? Are we two?
No, less than.
No, at least 1,500. We want to go bigger than 1,500. At least 1,500. We want 1,500 or bigger. So at 6 years, we're not there yet, are we? So what do you do from here? You grab the calculator and you try the next one. Or might you jump? Maybe you don't want to just immediately try the next one. But what I would suggest, grab the calculator, and if we're just going to try 7, I'm fine with just trying 7 because really we're kind of close, aren't we? So I'm going to type in 1,000 times 1.05 raised to the power of 7. That's all I'm doing on the calculator, guys. Did you get what I got? At 7, it's $1,407.10. Am I there? No. So now what? Try 8. And if you're going to tell me, okay, this is where I jumped to 9, that's fine. But just make sure, once you have your answer, make sure the one below it does not work. Does that make sense? And I agree, we're getting close, so I think I'd be careful about how much I jump. A lot of you guys use this calculator, yes? A shortcut if you don't want to have to retype it all. Since I still have this on my screen, if I hit the up arrow, it will take me back into my line of work. And I can just arrow over and replace that 7 with an 8 and hit enter again. Okay? So at 8, what am I at? $1,477.46. Am I there yet? No. Well, Levi already told us the answer. What's going to happen when we try 9?
I think it's going to work out.
Think it's going to work out? Hey, guess what? When you put in 9, we're now at $1,551.33. So what's the answer to this question? 9 years, right? How many years will it take for the count to grow to at least 1,500? What is the first time we were at least 1,500? And that is 9 years. Okay? Now, Levi said he had started at 10 and he had a number that was too big. So what did he do? He worked his way back down. Now, I hope, Levi, once you found 9, did you try 8 as well?
Yes.
Okay. And my whole point is, once you decide 9's the answer, make sure the number below it is indeed too small. Okay, got it? What do you think about the next one? Can you do it? Try the next one. Yep, grab a calculator. You weren't in here before class when I gave that direction. Make sure we have calculators with us today. We'll need them. Go ahead and get your formula set up. I'm going to go ahead through and write down my information. And then grab the calculator and try it. See if you can come up with your own answer. Let's see. This time my initial value is 500. 3.5%. My R is going to be 0.035. And this time we're looking for at least 650. Oops. Any luck? Did you get an answer? Don't tell me the answer yet.
Okay.
Where's your calculator?
It's not being concise, then you can close the numbers that tells you.
Well, it's not working because it's blank here. I need a working calculator in your hands. Really? No one whatsoever.
Nope. Why would I want to do work when the calculator does it for me? That's what calculators work.
Well, you're involved. I give you credit there, but notes are helpful. You were involved. You know, you were answering my questions. You were. Okay, do we get an answer? Whose fault is that?
Who's fault?
Mr. Kogan?
I'm sorry.
Nobody's not.
Try it.
Yeah,
Let's keep you waiting. Try it.
Yeah, pull up all night.
Well,
You say,
Yeah, I think it's the good thing.
try the problem though. That'll help keep you awake if you're working it. Okay. Curiosity, what number did you guys start with?
5. Yeah, 5.
10. I started with 9.
Randomly? Just,
Nope.
I guess the last one was 9, wasn't it? So, okay. So here's the deal. We didn't have a starting point like last time, did we? Did anyone start with 1?
2. No.
2? And here's the deal. Are any of these wrong places to start?
Yes.
No, none of them are wrong places to start. I mean, I'll be honest, in my notes, I have 1 listed here. Would I have started at 1 if I was doing it on my own? I don't know. But if I start at 1, I don't know if anyone started at 1 or not, but 517.5. If I start at 1, right? Tell me, am I anywhere there, near there? Not really, okay? Do you have to keep going all the way up? 2, 3, 4, you know? No, you don't, okay? I heard someone say they start at 5. What'd you get if you start at 5?
6.
It was 593.4.
Yeah. Okay, so if you kind of do a jump there, that's fine because 593.84, am I there yet?
No.
No, I'm still not there. Now, I would be cautious how much more I jump. I don't know, would you guys do 6 or would you jump?
I don't.
Okay, I was kind of thinking 7, but I guess I'm thinking 7 because I know where my answer is. And again, as long as you're checking numbers around it, so if I want to check 7, What's 7?
636.44.
Okay, 636.14.
I chose,
I'm getting closer, aren't I? What?
I said I chose A.
Okay. So at this point, I'm definitely not going to be jumping at it because I need to see where it happens, where we hit that 650 threshold. And at 8, we get
658.4.
658.4. Okay, what were we looking for? At least 650. Did we get it? Yeah, we got it at 8 years there. Don't be afraid to grab the calculator and do the work, guys. That was not difficult work, was it? That's stuff you should like doing because you get to take the calculator and you get to just play. So, okay, one other thing, and that is example 4. Example 4, there's kind of 2 parts here. Notice the title of writing an exponential function. One of the things we need to be able to do in this chapter is to be able to write the equation. And so we're going to talk about how to write the equation, and then we'll talk about how to answer this. So the population of a given species decreases by 20% per year. If the initial population is 150, how many of the species exist after 11 years? Okay, do me a favor. Ignore this last part for the moment. How many of the species exist after 11 years? Ignore that for right now. That's the question we'll answer in the end. Right now, what I want to do is let's write an equation to represent the situation, because that's something you'll be expected to do. Now, what's provided here? Okay.
Balance after 2 years.
Okay. So initial population is 150. What is that? Excuse me. That is our
Initial value.
initial value, our A. What about this 20%?
Balance after 2 years.
No. It's our rate. What do we use for 20%?
0.02.
0.20.
0.20 or 0.20. I don't know why it's so hard to say, as long as you can write it down. Move the decimal 2 places left, correct? So 0.2 or 0.20. What do you have to pay attention to here? It decreases. So what's going to happen when the fact that it decreases?
Subtracting 0.2 from 1.
Yeah, we're actually going to be subtracting because this is a decreasing situation. So instead of doing 1 plus 0.2, we're going to do 1 minus 0.2. Okay, so with all of that in mind, I'm going to use our basic equation we have been. A of t equals A times 1 plus r to the t. A of t is what you're trying to find, right? If we're just trying to write an equation, we're trying to find the amount after t years. A, my initial value is 150. What am I doing for 1 plus r?
Minus r.
1 minus the 0.2. And then for the moment, raise to the power of t. Because we're just I just want you to write the equation. We're not answering the situation yet. I just want you to write the equation. Now, what's the cleanup we can do here? 1 minus 0.2 is 0.8, 0.80. So when you are asked for an equation, one form of the equation you could give here is this right here. A of t equals 150 times 0.8 raised to the power of t. I'm going to give you an or option here. You could also write this with x and y. Remember how we start off this chapter with y equals a times b to the x? You could also write it of the form y equals 150 times 0.8 to the power of x. That's equally correct. There's nothing that says what variables you have to use. So whether you use x and y or t and a of t. Now, you know the part I told you to hold off on? I'm ready for that part. How many of the species exist after 11 years? So what do? Yeah, put 11 in for the exponent. So either 11 in for t or 11 in for x. Does it matter which way you think about it? No. So if I just work over here, 150 times 0.8 raised to the 11th. Grab the calculator, do the button pushing.
1.88.
And it's a big long decimal, isn't it? 12.88490189, so on and so forth. What would be an appropriate response here for an answer? And I can.
13.
I'm going to go with 13 because we're talking about how many of a species exist. We're going to probably give whole numbers. In this situation, I'm just going to say round to the closest number of 13. I know sometimes people will say, well, I would just argue 12 because we don't have a full 13. But we're just trying to figure out about how many would exist. And so approximately 13 is good.
Yeah, 4,
Okay.
That's good.
Do watch your rounding directions on homework. If it's money, they tend to want to nearest cent, so they want 2 decimal places. If it's something like a population problem, they're going to want nearest whole number. Okay? So just beware there. Okay, you guys have some time, and I want you using it. You need to get on the iPads and be working on lesson 7.1 in Math Excel.
Yeah. If he's missing a leg, yeah.